Let us see the fourth set of chemical reaction in which we are going to study the oxidation of alcohols. Now, when we study oxidation, oxidation is nothing but removal of hydrogen. Now, in case of this, we can also see it being referred as dehydrogenation. So, hydrogenation is nothing but removal of hydrogen. What happens over here, look at it, is this is an alcohol. We have a hydrogen which is removed from a carbon atom, as well as a hydrogen is removed from the oxygen of your hydroxy group. It's clear to understand from this that that means a carbon which is carrying a hydroxy group should bear minimum one hydrogen for it to undergo this oxidation reaction. So, it's clear that only primary and secondary alcohol will undergo oxidation reaction. Okay. So, it is very simple, you have a hydrogen removed from here and a hydrogen removed from here, and thus to fulfill its valency, carbon goes to form a double bond with oxygen. Now, let us see some more examples in this category. We have RCH2OH, which on oxidation, here removal of hydrogen takes place from this place, removal of hydrogen takes place from this, and you obtain a double bond between carbon and oxygen. A primary alcohol goes to give you aldehyde as your product, which on further oxidation gives you carboxylic acid. Now, interestingly, look at it. Oxidation over here means addition of oxygen. This is the oxygen which is coming up over here. It's addition of oxygen which is taking place. So, what we find is primary alcohol on oxidation gives you aldehyde, which further on oxidation goes to give you carboxylic acid. Similarly, I will have a few examples showcasing this by also mentioning what are the different types of oxidizing agent that we can use. So, let us see the first example. We have RCH2OH, which is an example of a primary alcohol. We are making use of chromium oxide, which is an oxidizing agent, to give us aldehyde as our product. So, hydrogen from here, that's a carbon, and hydrogen from here has been removed. You are left with one hydrogen over here, that's been shown here, and a double bond O. Now, note that a secondary alcohol, here is an example, undergoes the oxidation in a similar manner, and it is going to give you ketone as your product. It's very easy to understand. Look at it, hydrogen from here and hydrogen from here is being removed, forming a double bond between carbon and oxygen. So, here it is clear that a primary alcohol gives you a aldehyde and a secondary alcohol gives you ketone. I made it clear first itself that we need to have a presence of a minimum one number of a hydrogen atom for it to form these kind of a carbonyl compounds. Now, when I talk about tertiary alcohol, these tertiary alcohol rather undergo elimination reaction. So, this elimination reaction of alcohol are going to give you alkene as your product. So, tertiary alcohol on use of this chromium oxide is going to give you alkene as your product, because it does not undergo oxidation, it will rather undergo elimination reaction. But what happens is, if I go to make use of a strong oxidizing agent like potassium permanganate, what we find over here is, we find that at a raised temperature, tertiary alcohol may undergo the reaction in order to give us carboxylic acid, and these carboxylic acids which are formed will have less number of carbon atom than that of the starting reactant. So, this is very much clear to all of you, I suppose. We are seeing one more reaction here, and in which we are having prop 2 in 1 all as our example. So, this is our starting reactant. We are making use of an interesting oxidizing agent, that is PCC, pyridinium chlorochromate. Now, it is note different that this is going to again show its nature of carrying out oxidation over here. So, there is removal of hydrogen from here, there is removal of hydrogen from here, thus going to give you C double bond OH. But what is the speciality of PCC is that it does not harm the carbon-carbon double bond, because oxidation meaning there is every possibility that over here addition of oxygen would have taken place, but it doesn't happen. So, it retains this particular carbon-carbon double bond. Okay, it doesn't disturb this carbon-carbon double bond. So, that is a speciality of using pyridinium chlorochromate. We are also seeing one more set of the oxidizing agent, and that is copper at 573 Kelvin. Here we are seeing three examples, that of a primary alcohol, a secondary alcohol, and that of a tertiary alcohol. Same way, primary alcohol will give you a aldehyde, a secondary alcohol will give us a ketone, whereas tertiary alcohol will undergo elimination reaction giving you alkene as your product. So, this is with respect to oxidation of alcohols. What we find is primary and the secondary alcohol undergo oxidation to give us aldehyde and ketones respectively. Tertiary alcohols undergo elimination reaction, thus giving alkene as the product.